Hello everyone, Ram Ram Saryano. This is our day 7 reaching master in Codeforces, and our today agenda is things to do is we will be doing lead code POTD as usual. Then we will be attending a virtual contest of Codeforces creating by ourselves because there is no contest having today. So we will be attending the Codeforces virtual contest and solving it. That is the plan for today. So let's start, don't waste our time. Okay, so let's jump to the lead code POTD. This is day 6 of this month. So the question says maximum number of integers to choose from a range I. Okay, it's a range question, range query question. You are given an integer band. You are given integer array band and two integer n and maximum. Okay, two integer n and maximum. You are choosing some number of integer following the below rules. Okay, choosing some number of integer following the below rules. Choose integer have to be range in 1 to n. Okay, the integer should be from 1 to n. Each integer can be chosen at most once. Okay, the chosen integer should not be in the array band. Okay, it should not be in this band array. The sum of the chosen integers should not exceed maximum. The sum of the chosen integer should not exceed maximum. What does this mean? Okay, return the maximum number of integers that you can choose from the mentioned rule. Okay, band equal to 165. These number are band, and we have given 1 to, so we can choose number from 1 to 5. Our maximum set should not go up to 6. So what is the maximum number of integer we can choose following the mentioned rule? Okay, so you can choose 2 and 4 from range 1 to 5. Both did not appear in band and the sum is 6, which does not exceed limit. So we can choose from this side of the, from 1 to n. N is what? N is 10 to the power 4. Okay, so it can be done in n square also, because the constants are, no, max sum is 10 to the power 9. Then also it is like 10 to the power 6 or 7. It can be done in a linear way. Okay. How many number? So 1 2 3 4 5 6 7. Okay, we can skip. Can we do it in linear? Just traversing through n, checking it's in there from right side only. So here is 0 because 1 cannot be put, so sum is greater than. Okay, band is 11 and 7, so 50 is sum over, so we can choose 1 2 3 4 5 6 7, and this sum will be okay. So the maximum 2 to 4 5 6 7 will be over. Can we do it in a linear way? Can we? Int. Let's take long int. Long sum. I know 10 to the power 9 can hold int. Let me check. Is 10 to the power 9? Okay, yeah. In range of int. For int range plus minus, you can write in between. Yeah, we can write in int, but for safety purpose, we can use sum equal to int long. Okay, next, just vector of unordered set of int band. Okay, so band dot begin, band dot end. This will fill all the element of band. Okay, then simply loop from int I equal to 0, I less than n. Okay, the element equal to, okay, from range 1 inclusive, no, I think we can take 5 also here. 5 plus 6, no, 4. Okay, so we are starting from 1 to, so we can take, I think, I feel So n is 7, so we are taking 7 also here, so yeah, we can take. So from I equal to 1, let me check, is this that much easy or I am wrong somewhere. If not band dot count I, if it's not in the band list, we simply sum plus plus, okay, sum plus plus, let me also sum plus equal to I, okay, we sum. If sum is greater than max sum, so we simply break here, okay, we simply break here and count plus plus, and at the end return count. Is that much simple is this question. For the smaller test cases is passed, but let me check for the, yeah, that was it in the question. Can we do it in more simpler way without using this hash set, matlab unordered set? Okay, that why 65% people have done this. Can we do it? We don't have to think about that. There is no follow-up question here written also. It's easy one. Okay, let's forget it and jump into Codeforces, and we will start we simply start a virtual contest. So we get a time mannered also, like simply here go div 2, div 1, div 1 plus 2 educational round. Okay, these are the contests we want, and rated doesn't matter, tied, no summation, like there will be no summation, we haven't tried it yet. Okay, and just randomly pinging it up. Oh, we can directly start here virtual contest also. Okay, here virtual contest as individual, yeah, no, we don't want to wait any. In 38 register. Okay, so here is our, so here will be some modulus 9, okay, what will be this? Okay, make all equal. Guess the tree. What happened? Sorry guys, what just happened is I disconnected my monitor. Wait for a sec. Okay, so we are like connected again, and are you able to see my, let me check it. Yeah, you are able to see it, I feel. Okay, so just you are given a cyclic array a1 a2 an. You can perform the following operation on a at most n minus times. Okay, let m be the current size of a. You can choose any two adjacent element where previous one is no greater than the later one. Okay, in particular am and ai are adjacent and am is the previous one. Okay, and delete exactly one of them. In other words, choose an integer I less than m where AR of I is less than or equal to AR I of mod I mod m plus 1. This will be the second index. Hold and delete exactly one of the AI of and I mod m plus 1 from A. The goal is to find the minimum number of operations need to make all the element in A equal. Okay, the goal is to make all the element in equal. So what does this mean? I mod m plus 1. I mod m is the, in particular m, what is m? So let m be the current size of A. Current size of A. Okay, when we delete something, m will decrease by 1 also, and delete any of, then we can delete I also, so it will become, we need 0 operation here, we need 2 operations. Okay, we can delete this, and here we need only 1 operations, here we need 1 2 3 4 5, so we need 4 operations. Here we need 1 2 3 4 operations also, 6. So we cannot count or just delete it. Can we do it? 1 2 3, so 1 2 3, we can delete 3 here, and 8, there is 2 8, 1 2 3 4 5 6, we can just count and delete it. What is the difference of I mod m plus 1? We can choose 2 adjacent element. Okay, we can choose only 2 adjacent element and delete any of them. So when we let m be the current size of A, you can choose either 2 adjacent element where previous one is no greater than the later one. Previous will be smaller. What is it? You can choose any 2 adjacent element. Okay, here previous one is no greater than the later one. Previous one should be smaller. That means in particular AM and AI are the adjacent. AM is the previous one and delete exactly one of them. In other words, choose an integer I less than m, where error of I is less than, it should be greater. You can delete 7. Okay, 3 4. Choose the element I equal to 2, delete A3 in the second test case. Then A would become 1 2 3, you deleted 3, and then okay, output the line containing an integer minimum number of operations need to make all the element in A equal. Okay, Okay. 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 Why I forget every time how map works? Why? I don't think that it will pass on here. There will be some more, but let's try. Why? Just go with intuition, just go with gut feeling for one time. Then check out a pen. It will fare on test case 2. If it get correct, we will be proofing it after the contest, how it like working. Just if it gets selected. Okay, so that was it. Generate permutations. There are an integer sequence of a of length and where each element is initially -1. Okay, integer in the variation. Mishuki has two typewriter where the first one writes later from left to right. Okay, with a pointer initially point to 1. Okay, and the other writers from right to left with a pointer initially pointing to M. Mishuki would choose one of the typewriter and use it to perform the following operation until A become a permutation of 1 to N. Okay, write number where the minimum positive integer that isn't present in the array A to the element AI, where I is the position where the pointer point at. Right. Okay, so 1 1 2 minus 1 4 3 1 3 1 2. Okay, 3 1 2. Okay. Just so there are two typewriter where the first one write later from left to right and with pointer initially at point to 1, and another write from right to left initially N. Misuki would choose one of the typewriter and use it to perform. Okay, Misuki would choose one of the typewriter and use it to perform the following operation until A becomes a permutation of 1 to N. Okay, typewriter write the minimum positive integer that isn't present in the array A to the length A of I. I is the position where the pointer points at. Okay, such operation can perform only when AI equal to -1. Okay, minimum number in the array of AI to the element AI. Minimum positive integer that is present in the array to the element AI. Okay. carries return the pointer carries return the pointer to its initial position 1 for the first typewriter and for the second. Okay, move the pointer to the next position. Let ai be the position the pointer points before this operation. If Mishiki using the first typewriter, I equal to I plus 1, I minus 1, otherwise. Okay, such operation can perform only if rather the operation holds I is less than equal to, if after the operation. Okay, your task is to construct any permutation p of length n where the minimum number of carries return operation needed to make equal to p. Return the pointer to its initial position. Okay, what does this mean? Carries return the pointer to its initial position, i.e. 1 for the first typewriter and for the second typewriter. When happen? She is using the first typewriter such that a minimum number of carries return operation needed to make a equal to p is the same no matter which typewriter Mishiki is using. Okay. The first typewriter, it's possible to make pi with 0 carries Carter operation. Okay. In the second test case, it is possible to make p equal to 1 2 with the minimum number of carries Carter as follow. In Mishiki, the first typewriter, write 1 to a becomes 1 minus 2. Move pointer to the next position I2. Write 2 1 2. If Mishiki is using the second typewriter, move pointer to the next position 1. Write the 1 to ai. A becomes this much. Okay. Return the pointer to 2. Write the 2 to ai. So this permutation is not valid. Why? Once again. Here what is saying is carries return the pointer to its initial position. Okay, I for first writer 1 and n for second. Okay, one 2. Move the pointer to the next position, that is I1. Write number, write 1 to ai to become this much. Return cursor to pointer 2. Write number 2 to ai to become 1 2. In the third case, p1 2 3 with 1 carry is written with the both the first and the second typewriter. Okay, for odd I think it is possible. Right, the first typewriter was move what he do in okay, so we have to move first one, so that means we end this and this. Okay, okay. For odd I think it is possible, and we have to just print a permutation of any. For even it is not possible, I think, because when we go to second, like here we for write I to AI it becomes this much, then we have to go to second and we write this, and then move the pointer to the next position I1, right, write 1 to AI, so A becomes I, so carries return to pointer 2, return a number 2. I think for even it is possible, for odd it is possible, for even it is not possible. And we can print any permutation, I feel. No, we cannot print any permutation. We have to print a specific type of permutation. Let me just see if there is. How is the position with pointer? Okay. One, two, three, and 4, 4. Okay, we can do it like that. Okay, so I get the thing, I get the feeling that I'm thinking is right. I don't know, but just let me check it. Okay, let me just try run it here. If we getting number which is 5, so that is 1 2 3 4 5. What will be here is 4 5 1 2 3. So what is the carriage count here? 1 2 3 and 1 2. Okay, and for here just come here, 1 will for this. What we can do is 1 2 3. There will be 3, I feel. Okay, it will be like n moves. What is the minimum? No, this is not minimum. 6. How can we make it minimum? Just if we make it, if we move to here and 4 5, we write 4 5 here. It will be easy. We can write here 1 2 3. No. Okay, so what we can do is like 1 2 3 4, and we can write here 4, and we can write here 4 5. Okay, so or we can do it like this also. Like here will be 1 2, return here. Okay, 4 5 1 2 3 4 5. So 1 is needed here, and here will be needing how much? So we can do here, but when we come back it will be not too much easy for us. So what we can do is here 1 2, then go forward, but when we come back then it will be very bad for us. So at least we have to make it forward. Come here and let's say it 5. Okay, here we can do this. Okay, 1 second, let me just 1. Second, 3 1 2. Okay, 3 1 2 1 2 is 1 2 1 2 and 3. So it taking 1. We going from here. So come here 1 2, and you move to here 3. So here taking 1 only, but for 5 1 2 3 4 5 you are going 1 2, and then coming here, and 3 4 5 is taking 1, and from here you are coming here 1 taking 2. Okay, 1 2 1 here is 2. 3 4 5. Coming is 4 5, so 1 2 3. No, this will be wrong. So here is 5 1 2 3 4. We do this, take one only for this thing. Cannot. I'm not coming with the solution. Why? Just divided by 2. If 3 was divided 2 plus 1 is equal to 2, 5 divided by 2 is equal to 4 plus 1 5. Sorry, 2 plus 1 3. So 1 2 3, and here is 3, but I am confused what to write here. 1 2 3, here 4 5. So here it will take 1 2 3, and 4 5 is 1, or 5 4. So it will take 2. So it will come here, then here will come 2, and for this here come 1, 2 is 3, and 4 5. Okay, I get it now. It will, so he will come here, then it will 2 3 4 5. Okay, get it. What will be the permutation? So until divided by 2. Okay, if n mod 2 equal to 0, see out. No. Okay, then if it is not like 0, if it's an odd thing, then simply what we do here, for 0, we have to see out the first. We have to just half int less than n by 2 plus plus 5 divided by 2 equal to 3, less than 3. Okay, here is right. See out n. Okay, here is thing. Then for int I equal to n divided by 2, I plus plus. Five divided by 2 is what? 2. No, we don't want to 2. We wanted 3. Okay. Here is 1 2 coming. What is going on? Continue. Okay. Continue. 1 2 why is not 3 coming? So here will be 5 4 no? Okay, 5 4, so opposite 5. Here should be minus minus. Not less than I is while is greater than. What I am doing, man? Why I am doing these silly mistakes? Let me check if my code gets submitted or not. Fail on second test case, I feel. Okay, it got accepted. So that was the thing. And nice. Then what we do is go to problem statement and pick the third question. We have a lot of time, we can do the third question also. Guess the tree. Okay, this is an interactive problem. I haven't done it, but let me read it. What is saying is Misuki has chosen a secret tree with n node index from 1 to n. Ask you to guess it by using query of the following type. Question mark AB. Misuki will tell you the node x minimizes this, where d of x y is the distance between the node x and y. Okay, dxy is the node distance between x and y. Okay, if more than one such node exists, Misuki will tell you the one which minimizes dax. Okay, find out the structure of Misuki's secret tree. At most 15 query. I have interactive question is not one of my expertise, so I will leaving it and moving to the fourth question. When I am confidence I have learned the interactive question, then I will be solving this. Okay, longest max min subsequence. What is this question? Longest max min subsequence. You are given integer sequence a1 a2 an. Let s be the set of all positive non-empty. Okay, all positive non-empty subsequence of a without duplicate element. Okay, subsequence of a. Your goal is to find the longest sequence in S. If there are multiple of them, find one that minimizes lexicographical order after multiplying term at odd position by -1. Okay, find the one that minimizes lexicographical order after multiplying term at odd position by -1. Okay, for example, you're given 3 2 3 1. The set 1 2 3 2 1 2 3 3 1 3 2 2 3 1 3 2 1, then 2 3 1 and 3 2 1. That would be the longest. Okay, and 3 2 1 would be the answer, since -2 -3 2 -1 is the lexicographical smallest, smaller than -2 3 and -1. Okay, that does not contain duplicate. Okay, and the our okay, we can do it with the binary search, the subsequence part, but the thing here is we have to maximize the odd elements, the first odd elements. Okay, then it will be the lexicographical smaller, then minus 2, 3, minus 1. Okay, because minus 3 is much smaller than minus 2. A sequence C is a subsequence of sequence D if C can be obtained from D by deletion of several possible 0 or all elements. A sequence C is lexicographically smaller than the D if only if one of the following holds. C is the prefix of D but C not equal to D. If only if C is a prefix of D okay, but C is not equal to D in the first position where C and D differ. Okay, the sequence C has a smaller element than the corresponding element in D. Okay, not equal and smaller. Okay, the first element differ and whatever the smaller it will be the maximum one. Okay, so we have to check only the 3 possible. What 3? Okay, I get it. What is the value of A? What is the length of array A? 10 the power 5. So we have to solve it in n log n, or so n log n it's a binary search, then we can only use binary search to find the sequence subsequence. So 3 2 3 1 3. No, yeah, the lecture multiplying. Okay, so we don't have to we just have to eliminate the negative element. Okay, so we have to find the largest, so we have to remove the duplicate element, and the first duplicate element should be not removed, the second duplicate element should be removed. Okay, the first should remain intact in that position. Okay, so if we find the if we go here, if we find another 3, we should remove it from the array, we will not insert in our array. Okay, if we find 2, only 1, then we insert it. Okay, this will be the answer, I feel. Okay, 3 2 3 3 1. Okay, 2 3 1 should also be answer, no? 2 3 1 3 2 3 is also 1. Okay, this is answer 1, this is answer 2. There could be n answers at least. Yeah, there could be at least an answer. There could possibly an answer. But if 2 is greater than, if it's less than 3, but we have to find the greatest also. So what we can do is, can maintain a distinct element size. So we can check from here to here how many distinct elements are there. 3, here from here 3, here from here. We can do it like that also. Just let me get in the whiteboard, so then we will understand more. Okay, so this is a sequence. V3 is here. Okay, 2 can come here because it is a distinct element. 1 can here because 1 not present in here. 3 is present, so we cannot make 3. But what we can do is, before the 3, this can be a part. This could be also a answer. Okay, this can be done. Okay, this could be answer, our answer. We can see we can store where 3 is present in this num, and we can check if this is smaller than this, the first element of this. Okay, if it's greater than this, we cannot like. And what is the length of this and this? Okay, we can check. If it is 4 5 3 3, so we'll like, there is one answer is this 3 to 1, but 3 is greater, so we will taking 3, and here is 4, so we also wanting the largest one, so 4 will come here, sequence. Okay, then 3 again, so here will be not 3. Okay, 3 again, so 4 will come also here, and 3 is again, so this could be our answer, 2 1 4 3, but it is less than 3 1 this size, whole this size. This is no 1 2 3 4 5, 1 2 3 4 5. This is similar. Okay, if it's greater than, so what we can do is, okay, get it something. If we find the length same, and if we find the length same and this element is greater than this element, we can pop it back also, so this remain our the greatest. Okay, and then like 3 comes. Let me see, if there was a 5 and this is same, so this is greater now, so we always take this and then 5 comes. 5 is, yeah, if 5 is here, then we check 1 is greater than 5. If not, then we will not simply take this 5. And 3, like 3 is already here, 3 is already present here, and what is the size of this and what is the size of this, whatever is greater we will take it, and we will also check like this size. Okay, only if the first is matching, if it's coming, then we will take. Okay, this could work, I feel. Let me like run in this example. Let me check I am right or wrong. So 3 is not present, so we are taking 3, then 2, then 1. Up 3 is present, but 2 is less than, so we will not take this, we will simply leave it. Then 2 is also present, and the we'll check then like this size, or why will we like leave this one? We don't require this. Okay, so we'll leave 2, because 2 is not greater than this, and the size is like always smaller, because 3 is this, and if we take 1 also same 3, then the size of this will be like 2 1 3. Why will we take this? And this is 2, so why would we take 2 if this size is like, no, we don't have to like take 2, because this will be smaller. Then maybe no, 3 to 1 is the answer, I feel. 3 2 1 or 3 1 2 is the same, I feel. No, 3 1 2 is much more. What is this? Example, input output. There are 2 test cases. One second. For the each test case, output the answer in the following format. Output an integer in m, the length of b. Okay, this is 3 and 2. Should be smaller. -3, 2, -1. Once again. This means is like this is not an answer. Then 3, I will take 1. 3, 1, 2. What is the sum of 3, 1, 4 and it's 2? But it is saying the for the first element only. We want that it should greater. If there is multiple, find the one that minimize the lexicographical order after multiplying term at order. Two, 1. -2, 3, 1. in odd position we want what could be the sequence of this? Total number of, simply the total number of distinct element. So 1 2 3, we can only make 3 here. Okay, we know that much. What happened, man? I don't know what happened to it. So we have 3 places to fill. Okay, so and what are the sequences of 3 places? We can have like, if what we can have is 3 2 1 3 2 1 3 2 1 3 2 1. Can swap it also. Okay, like if we have 3 2 1, we can only put 3 2 1. Okay, if we get 3, we can like put 3 here. We have a choice at end. If we get 2, that means we can put 2 here also. Like these 2 we can swap now. If we, so these elements we can swap. If we get 2, if we get 1, now these 3 elements we can swap. Okay, we can also get 3 2 1 2 3 2 1 3 2 1. Okay, we can like swap up. It's a sliding window problem. No, it cannot be a sliding window problem. How we can do it, man? I'm not getting it. We cannot use dp simply because the constants are too high. 10 the power of 5 length of a. To come up with a linear solution only. 312 is the answer for this. 312. let me check for this one what the answer should come. Oh, bad bro. The yesterday contest was too bad. I only come up with one solution. And the second was very easy, but I didn't get the intuition. And third one I stuck. Like it was a easy. Third one was like pretty easy, but I also got the intuition how to solve it, but I don't know why I was not able to solve it. But the fact is I only solved one question yesterday, and I got a pretty hard minus in that contest. So 5 2 1 7, okay, 9, there is 7. So like which 7 would you use, like this 7 or this 7, and you have a choice. If you the next will be 1 2 3 4, it will be greater. If you don't, you would use this. Okay, 7. You have 2. Which 2 will be using? Like this will be, if you remove this one, the next will become even. So this is 2 greater, and this is like so this 2. Okay, and if you use this, like what is the position of till now? -1. You have to check also. Like this 2 for this 7. If we remove it here, 4. 9 will get more here. The 9 will be in 1 2 3 4. So 7 is less and 9 is more. So why will we remove this and make that this is 7 is great and 9 will be odd? Okay, so we don't use this one. Okay, and we use 7 here, and we have 2. Okay, so 2 is here less. Okay, it will come to here. Okay, so we don't use 2, this 2. Okay, and we don't. It's 5. 5 we already used. It's in first position, and it's in like, so 5 would, and it's 2. If we remove this, it will become less. So why would we use? And this for same, and for 2 same. 5 2 1 7, 5 2 5 1 9 7 2, 5 1 9 7 2. Answer is 5 1 9 7 2. Okay, so it's less than. And what about you, bro? How was your contest? Like, how many questions you have solved yesterday? If this was a DP question, if the constant were low, I can do it, because the sum of odd places will be greater than the sum of these places, or the elements of the odd can be maximized. Okay, you solved to like AF, मतलब A B C D E F. You solved 6 question. Great, bro, great. In that 2 hour. Again, 52179. Very great, bro. So, how many years you have, like, how much time it like take you to become a specialist? Can you share your story? 5217. What is this? 5.97. So for this two is so one should be here and two should be here, like, so if I say 5, okay, two, okay, 1 7 9. Now this, if we count 7 again, simply check it's 2. Okay, if 2 is present somewhere else, okay, here, okay, like 1 is greater, nice, bro. How many questions you have solved in lead code? Like, what are the numbers? You also do lead code contest, weekly contest? And what is the rating of your lead code contest if you do? 52179. Okay, I'm not getting it. It is minus 21321, so the answer is 321 minus 321. The second example is okay, 2000 rating, nice. My lead code like rating is approx 1600 or something, 1650 above, greater than that. And how many questions you have solved? Like 2000 question, or is it your rating? How can we do? We have two choices here. Okay, nice, bro. So can you suggest me like how to solve question in like Codeforces? I am stuck, man. 900 question, great. I also solved like 500, approx 500 question on lead code. I feel lead code is very easy than this Codeforce. The question are pretty clear, they are well explained in short, but here I don't understand the question itself for a 30-minute sometimes. See the prefix of D. C the prefix of D and C not equal to D. Yeah, bro, too much observation. See, prefix of D means Okay, that this would be same and C is not equal to D. And nowadays how much minute it take, like 2 minutes or 3 minutes? How, like for the first 3 question, how much time you take like to solve the first 3 question? And did you like follow the TLE eliminator sheet or something like that, or you just solve randomly Codeforces contest? What was your strategy? Getting it, man. So what we can do? Dip 2. Dip 2, Dip 1, or Dip 1 plus Dip 2. Educational rounds. I can come up with a solution. I am not. First thing first, so we have to remove the duplicate element. Okay, and these are the duplicate element here, here, and here. Okay, the remaining will be 52179. Okay, okay, random. And how many question you like solve daily, when you got to X specialist, in between 4 to 5 months, how many question you solve daily randomly, like 4 to 5, 5 to 10? How much you grind like? So these are the, if we take simply from right side to left side without changing anything, so 52179 will be our answer. Okay, and we want the lexicographically smallest, so this will go minus, this will go minus, this will go minus. So we want this element as much great we can. That's the question, Srina. And the answer for this question is 51792. 51792. Okay, so why is this? Because 1 is less, 7 is also less, 7 is great. We don't want this. Like 5. Okay, then we take 2. Here let's take 1. Okay, initially we can like just take 2. Okay, thanks for sharing your story, bro. We have to make the odd elements greater. Okay, like here he has made it 1 2 517. Okay, is this a wrong? 51729, because he asked for the first, should be greater. There could be a multiple answer. 51792. This is not written. -1. I'm not getting it. I will be absorbing it. When lexicographical comes, simply we have to make small list, so it should be -1. One comes 4, 5. 7 comes, it's a 6. So here is 4. 5197. Okay. 7 comes and play. If you deleted it, the 9 goes to here. 9 and 9 4. Should we get why you want 9? You can also do like this thing. Okay. Next thing 5. Don't want it. If it's greater than 5, then we go to 8. Now the 7. I know that this has to be here. Simple thing. 5, 2, 1, 7, 9 is going to be here, and here we have to shuffle this only. We can only shuffle these. These 2 can we shuffle and come to any other. Here we have 2 more than only here, we have to here. There is only one place we can put at last, only this. We can put it here, we can put it here last. Okay, this choice we have. And for one, is there any choices for one? No, one will be here. And for Shrivan, yeah, there is two choices. We can put here and we can put here. These are the choices we have for Shrivan. Okay, after 9. Okay, we can put after 9. Okay, to 178. Lexicographical smallest. Just think them. Think what we can do. We have time 30 minutes. As you can see, the sequence की बात हो रही है, तो just eliminate every duplicate element. We can have 2 here. It's greater than the next value. Okay. One is the odd one. Now we check for here. Simply put it here. We don't have to check. Okay, wasting time. we can make a adjacency list out of this, I feel. AB basically will tell you the middle value, I think it will give. Okay, if I give AB, so it will give me middle value. Like if we take a diameter, if there are more than one such node, if the diameter is even, you will get one which minimizes DAX. Okay, so it will AX. Okay, so what does this mean is, let's assume we have take 5. Okay, 1 2 3 4 5. Okay, if we give 4 and 3, it will give is what the value is minimizes. So it's a even, we have 4 2 1 3, these two, so it will give what AB, this thing he will give me. Okay, what if we give 4 1, so the 4 2 1, so it will give me 2. So we can select 4 2 and 1 to 2. There is a what we are not sure that they are the parent or something like that. We have to make in a such a way that it should write. Okay, so we know whatever the value it gives, it will be small, it will be A2, X will be smaller always. It may be A2, Y is smaller, may not. What if this is, no, from this it is greater, I think it will be smaller. Always the smaller value will be this, like A minus X. That what it says. Or if the tree will be here, we can only make how much query, 15 into n. Okay, we can make only n times, we can make 15 into n times. Okay, so let's say 8, let's say 9, let's say 12. Okay, so 1 2 3 4 5 6 7 8 9 10 11 12. Okay, if we like 8 and 7, if we like 1 and 12, just do this. 12 is here, so what will he give? 1 and 3 he give. We can like 1 2 3 and 3 to 12. There will be like node. We cannot say a node, but we can say is there will be a path where 1 to 3 and 3 to 12. Okay, we have this much, and then after 1 to 11. So what it keep 1 to 2 there is a here, and we know 2 to 11 will always be there. Okay, we can small it. What if the query is 1 to 10? 1 to 10. So 1 to 2 will get it, and 1 to 2 to 10 also. Okay, the 2 to 1, 10 and 11. So we know that 10 and 11 will be children of 2, or 2 will be ancestor of this thing. Okay, these are the queries. Okay, so we'll make another query 1 to 9. So what the 1 to 9 gives? 1 to 2, 1 from 2, and 1 to 2 there is a path, and 2 to 9. 2 to 9. Okay, then 1 to 8 there is still 1 to 2 and 2 to 8. Okay, 1 to 9, 1 to 7. So it will give us 1 to 3 and 3 to 7. Okay, this will get, and what will 1 to 6, 1 to 3, 3 to 6. Okay, 1 to 5, 1 to 2, and 2 to 5. I hope this data will help us to find the answer. 1 to 4. 1 to 2 and 2 to 4. 1 to 3. 1 to 3. So what will give? No, it will give nothing. No, 1 second. A nearest connecting. So it will be 1 1, 1 to 1, and 1 to 3. Then if it gives 1 to 1 and 1 to 3, then you know, then 1 to 3 is a node, I feel. 1 second, let me check. You simply input 1 4 1 2 1 3. So like, what is input? You input na A B, and out will no. The distance between node and X and Y. That's what I was saying. Like we have 1 2 3 1 to 2, so there is will be getting 1 to 1 and 1 to 2. Okay, we know that there will be is let's construct this. What we have here is these two are the main thing. When we will get this type of thing, so we know that 1 is here, then 3, and here will be 2. Okay, simple. Okay, then we know 1 to 2 we have added, 2 to 4 we know there is 2 to 4 somewhere. Okay, 3 to 7 we know there is 3 to 7 somewhere. We know 2 to 5 we know somewhere is 1 to 3 there is added already. 1 to 2 we have already. 2 to 8, so 2 to 8 is something. Okay, 2 to 8. Okay, 2 to 8. Okay, 3 to 6 okay, 3 to 6. 1 to 3 is already there. 1 to 2 there is already. 1 to 2 it is already there. 2 to 10 okay, there is this thing. 2 to 10. 1 to 2 is already there. 2 to 9 is already there. 2 no, there is no 2 to 9. 2 to 9 is already there. Okay, 1 to 2 already there. 2 to 11. Okay, so 2 to 11 already. 3 to 12. Okay, 1 to 3 is already there. Okay, this is this thing. Okay, from 1 if we can do with 15. No, one sec. For the first, for the second, for the third, for the fourth. Okay, this is the data only from 1. Okay, if we do it with 2, what is the value of n? Let me check. The first line of the node, the number of node in the tree, hidden in the tree. Okay, the thing is, when we get like same thing, we are sure that there is a node between that. Okay, there is a edge between that. So is there anything we know, like when we do 2 and 4, this will like get 2, so we know there is an edge between 2 and 4. Okay, we can check every node for this, and we know for this also, we know for this we also, we know for this we. So what he is saying, the sum of n over all the test cases does not exceed 1000. Okay, the sum of n. So the sum of first 15 element 15 natural number is 120. 150 11,000 20 210 and 60 1840. What if it's a skew tree? We cannot do it like that now. 45 43 What will be the first natural number to the sum of leave it here. You know that it is approx 40 45. What if it's a skew tree? We have to like do it for every 40, then we'll come with a what if the tree is a skew tree? So we have to what if it's a skew tree, then we have to do for every 15, like every 45, but we have only 15. We will not get our answer. No, but it will be decreasing na every time. Like we don't have to check for the first will be minus, then the second will be at least -1, and then the 2, then the 3, then the 4, then the 5, then the 6, the 7, then the 8, then the 9, then the 10, then the 11, and the 12. Total we can do is how much operation? Let me just math. Total 15 into n. Let's see, n is 40 at most. So we can do is 0 5 4 2 4 6 600. We need 600 operation to know all the edges. Okay. For the first, we will be traversing 40 element. No, why will we traverse 40? If here, so we will 39. Okay, for first 39. Then for the second, it will be 38. Then for the 37, 37, 36. Okay, the sum of these are like what? The sum of these are, yeah, the sum of this will be this much. So we can do it. We can like opt the sum of first 41 number is okay. 861. Okay, so we can do it like that. I feel we can do it like that. Yeah, we can do it like that. So we just skip for that element, and we have that much query, so I think we are good to go. Yeah, so for that we will not checking for that. After that, if we get for those two also, we will not checking for the upper one. And that much it will be reducing every time. This much operation we can do, and it will be reducing every time to 0. Okay, so we can do it. Let me code it up really quick, but I don't know the how to do it. We will be using the data structure set here. Okay, set of int. So we'll check for 1 to every other node. Okay, when we find answer for 1, we'll be inserting 1 here. Okay, and we will be adding is when we find the same two values or whatever. So we will be creating this should be the parent and this should be a child. Okay, we will be adding over here. Okay, or we can do it using we can create our own this thing also. Okay, so this thing, then after that we will for 2 we will not checking for 1. Okay, we will not query for 1, and for second then we don't query for second also. For third we will not check for, because we have found the answer now. Then for 4 we will not check, and for 5 we will not check. From 6 to we will checking after that much. Okay, 7 8 9 10, this thing will happen here. Okay, and we will be building our tree as we go down, and after building tree we can DFS and print our answer also. We will be needing exactly 10 into 15, but that is the solution I come up with. I don't know I'm right or wrong. It may be right, because mathematically we will be only query for, let me check what is the first, the sum of first 45 natural number is 1035. Okay, so it will be 44. Fill. We can use 946 and for 44 it is 990. So we can have at most 44 element. Okay, so what will our time complexity go? Well, let me check. What is the time complexity for checking this? So 44 element we can have at most. We cannot go further for 44. So 44 into how to measure the time complexity? So it will be a constant number, so we don't have to so it will be a constant 40 n into n plus 1 divided by 2 na. So 44 into 44 plus 1, this will be the time complexity, n square. So 44 square will be our time complexity. So it's a constant time, so we don't have to worry. Yeah, it can work. I feel this can work. this solution, but I don't know how to solve the interactive problem, how to flush it. I haven't solved it yet, so I cannot code it up, but I know the logic. It definitely work. I will be seeing the solution of this, how to solve it, the intuition behind it, and I will be seeing my intuition is correct or not. I feel that this is correct for the third question, because 44 is what we can do, and we can check for 44th query. It will be 45, it will be 43 we will be using. We will be left 43 query we will be using. After that we will be using 42 query only, because for the first we find it how much is connected with, and for 42 for the next we will be for second we will be using 42 query only. Then it will be decreases and it will become only 0. So the total query we will be using is 6 and 44 into 15. So the sum of these query is equal to that much only. So we will get our answer, I think, from this logic, I feel, but don't know I'm right or wrong. So this interactive problem, if I know how to code it up, I can so I will be learning the interactive problem soon, how to code it and how to debug it, but not in that live session. And the fourth one I cannot come up with a solution, so I will be seeing the solution of the fourth one. And the third one is easy, I think. It's an easy question. Let me check what is the rating of this question. It should be 1000 or something. It's 900 rated, not more than that. I feel the logic is come in interactive problem is easy, but how to implement it very difficult, and debugging it, implementing it is very difficult. The logic could come by practice. It's not that hard, I feel. Why it's not coming? Acha, 1 minute is left, that's why. Okay, can we not exit this when it will be setting it up? Okay, so at midnight it will be, they will be setting down it for maintenance purpose. Okay. You can check I got a very minus, a 44 minus in the previous contest, and my rating goes to 990. You can check my latest rating is 990. Okay, so now can I check it? What is the rating of this problem? Still 50 seconds left. I will be checking the real quick the rating of this problem, and I will be editing the live stream here. And that's all for today. I only solved the first two questions, and the third I come up with a approach, but I cannot implement it, so I will be doing it that. And the fourth question I will be seeing the solution of the fourth question or a tutorial hint, whatever it can help. So yeah, that's all. for today. I will be solving it. Yeah, 1500. It's a binary search. DFS. Okay, so we will be DFSing it. So, and DSU. Okay. Interactive tree 1500 rated. For binary, where will we like using binary search? I don't know where the binary search use, but I know DFS and similar, like we have to DFS to get this solution, or BFS at DSU for like joining the, if we find the edge we can directly join with the help of DSU. Or one sec, with the help of DSU we can directly do it, na? Okay. Yeah, with DSU we can also do it, but with maintaining adjacency list and doing DFS on it, it's also very simple to think about. But DSU we can also do it. When we find the two like edge, we can directly join in DSU. It's also here, and we can also make a adjacency list, and as I said, we if we find it the edge between that, we can maintain a adjacency list and DFS on it. That will also give our answer. Okay, so it's a 1500 rated question, and I don't know where the binary search is applying on it, how to solve with the help of binary search. I don't know about that. Okay, there are two editorials. So hint 1, hint 2. Let me check the hint of third solution. Imagine you have an isolated versus indice. You can find any edge between two components using reasonable number of queries. Okay. Use binary search. Okay. What? Imagine we have an isolated vertices initially. Can you find any edge connecting two components using? Yeah, we can do it. Okay, we can do it with DSU. It's easy. Okay. Okay. And for that, can we see it? Length of the required section, no distinct element of x. Yeah, that we know. We greedily build the required when we select a odd index element for s to choose an element which is large as possible. Okay. I try to choose small as possible. Okay. Okay. So today's we can end the live stream for today, and I feel like if nothing comes over tomorrow, then we will be doing the lead code weekly contest, bi-weekly contest. I think tomorrow is the bi-weekly contest, so we will be attending that, so it will be a fun. Come tomorrow and join me. Okay, bye, done. Shubhratri to everyone and have a good night. Bye bye.